Welcome, everyone, to the Exploring Drones with Python on a Raspberry Pi session. We're going to talk really quickly about our project that we did as part of the Continuity of Learning initiative that Pennsylvania Department of Education had when the pandemic started in the summer, or last summer, I would say, before the school year began. And so this was our project where we did towards middle of the fall semester for students, so November, December, right before the holiday break, where we worked with For the Wind Robotics to get drones out to one of the partnering IUs, which was IU SITS, and they had about 8 teachers that participated in this project where each received a set of drones to use with their classroom, and the focus was really getting programming to kids who didn't have internet access at home. So IU SITS region, as well as our region from IU11, we have a lot of kids who don't have adequate access to internet, and so we were trying to figure out how do we make sure that they're still learning computer science the way that kids who do have access are learning. And so this project was really focused around helping kids continue learning with the same experiences that kids who have access have been learning. So we'll watch through that process um, during this session. There are 2 links there. One is the presentation and the resources that we had that are available that we ran with IU SITS, as well as our GitHub page, which has a lot of the code samples for the drones, as well as other activities with the Raspberry Pi. So we'll do a little quick introduction. I'll start. I'm Jidra Patel. My title is Innovation Strategies and Special Projects Coordinator at IU11. There's my Twitter handle. I'll hand it off to Dr. Eric Yoder.
Hi, I'm Eric Yoder. I'm the Coordinator of Educational Technology at IU11.
Tom.
Hello, my name is Tom McLean, and I'm the Director for Technology Services for IU11.
And so where are we? If for those that are wondering, we're located in central Pennsylvania. We provide services to 9 school districts in the Mifflin, Juniata, Huntington, and Fulton County. And so our demographic is very similar to a lot of the what the demographic looks like in IU SITS region, which is up here in the Clarion, Du Bois area, where they do have a fair amount of students who don't have access to internet. Some of them have, a very slow access to internet, like DSL lines, but a lot of them don't have any access, which is also very similar to what we have districts and families who don't have a lot of internet connectivity as well because of just the infrastructure not being there. And so when we started, what our idea with the project was is basically provide a remote workshop. So our Exploring Drone workshop that we did with IU SITS was completely through Zoom, and we partnered with For the Wind Robotics. So it was a 2-day workshop where they learned the basics of a drone, and which was done by For the Wind Robotics. And they got an overview of how the drone works, how to assemble the drone, how to put it together, what are some of the aspects of flying a drone, before we even got started with the Raspberry Pi and having them use Pi to program the drone. Because it's important to understand the basics of a drone before they can even dive into it. So this is what our objectives were for the workshop. And so basically we started with the idea of them having a basic understanding of what the Raspberry Pi is, how do you connect to it, what does it do. We sort of went through and explained the difference between the Raspberry Pi and other similar types of devices like the microbit or Arduino. A lot of people are usually bunch them all together, but they're vastly 2 different types of devices. So microbits and Arduinos are what are called microcontrollers, whereas Raspberry Pi is a microcomputer. which I'll do a little bit of a deeper dive in a few minutes about what the Raspberry Pi actually is. But having that core understanding is important because Raspberry Pi is a computer in itself, and so just like your laptop, just like your Chromebooks that you have, just like your desktop computers you have, Raspberry Pi is a computer, and you do everything on the Raspberry Pi. So Raspberry Pi can act as your web browser. It can be the place where you do the programming. It can be the place where you connect keyboard, mouse, monitors to. It's basically a computer in your pocket, a credit card sized computer. We talked about what the interface that we use to program in Python. We focused specifically on Python. So for a lot of you that are used to or have taken the CMU CS Academy through partnership with PDE that's available, that one is very much focused on running Python through the web browser. The other way of running Python is really on the device itself, and that's what we really utilized when we were running this workshop. With the Raspberry Pi, it does run Linux, so with Linux it's a little bit different on how you connect to it or how you interface with it with Bluetooth devices. So we talked about how do you connect to the Parrot Mambo. So Parrot Mambo is the drone that we use. It looks like this for those of you that haven't seen what it might look like, but each of the teachers put the drones together on their own, so they come in pieces, so they have to assemble the drone first, and once it's assembled, they're able to control it over Bluetooth. And then we talked about basic troubleshooting, and then we talked about the Kolibri platform, which is the platform that lets us deliver a lot of the content pieces in an offline environment without having been connected to internet when students are at home doing these lessons. So overview of Pi, I'll play this short video. It's the Raspberry Pi Foundation video, and it really just talks about what the Raspberry Pi is. Oops.
Computer that costs around £25, designed to teach young people to program and is capable of doing all kinds of wonderful things. Back in the 80s, kids had to learn how to code computers to use them, and as a result, these kids grew up with an inbuilt understanding of how computers work. Now, we need more programmers than ever before. So to deal with this problem, some clever people came up with the Raspberry Pi to reignite the spark. It runs Linux, a free operating system from an SD card, just like the one in your digital camera, and it's powered by a USB phone charger. You just plug in a mouse and a keyboard, connect it to a TV or monitor, and you're ready to go. In schools, not only is Raspberry Pi a great way to learn programming skills as part of ICT, there are also dozens of cross-curricular applications, like science, and music. And all over the world, people are experimenting with Raspberry Pis and attending Raspberry Jam events, where people of all ages are learning what can be done with a Raspberry Pi. Since the first Raspberry Pi was shipped, we've seen examples of people using the Pi in a variety of amazing and interesting projects, taking advantage of its size, portability, cost, programmability, and connectability. So whether you want to learn to make games, build robots, or even teach a bear to parachute, with Raspberry Pi, the sky's the limit.
So you can see how the Raspberry Pi has a really versatile device where you can do a lot of different things with it. And so you're not limited to just, connecting wires to it and making things light up, but you can also build more complex things, like a robot or a weather station or some sort of an automation device. In our case, we're going to be really focusing on how do you control a drone and what are some of the ways you could interface with the drone. So how do you build a controller, for the drone in Python that runs on the Raspberry Pi, so you can take it anywhere with you and use it as a secondary controller to to the drone, and so that really
And
becomes a way. Go ahead.
Go ahead. Sorry, Jacob, go ahead.
I was gonna say that really becomes a way for kids to be able to not rely on internet connection or a device that they need to buy separate. So they don't need an iPad, that they would control the drone with. They can just do everything from the Pi itself.
And the Raspberry Pi in this context, because this is a device that the ultimate goal was to send home with students during the pandemic, it made sense to use a Raspberry Pi and the Parrot drones just because for the price point. These are both relatively inexpensive devices to be able to put together, and small and portable, and could be shipped to students in a pretty small package without a lot of cost.
In our deployment, the way that the Pi, if you use the Pi, has a computer itself, all you need is a keyboard and a mouse, and you can hook it up to any TV that has an HDMI port. So, as most folks have TVs, they could hook the TV directly up to it. All they need is a USB keyboard and a mouse, which a lot of districts had laying around. So they were able to recycle some of that equipment, and the cost of the Pi with the SD card and the power supply came out to be about $60. And so for $60 plus the drone, you can have kids learning on a computing device rather than having to go out and purchase an iPad, which would be $300, or Chromebook again, which will also be $300, $400. And so from a district perspective, it was a huge cost savings in keeping the cost low for a lot of these teachers as well as students as they were going out. The other challenge was we saw that a lot of districts got hotspots to sort of bridge the gap of connectivity, but we found that a lot of these areas didn't even have cell phone reception, and so when you don't have a cell phone connection, using a hotspot it's unusable. And so how do you still continue to provide students in those areas with the ability to learn some of these things without having any access at all? This really became a way to do it. And you'll see as we talk more about the platform on how we were able to sort of deliver a lot of this learning completely in an offline environment. So they didn't need any connection, not even a slow connection. They could do everything that they needed to do completely offline without being connected. Couple other lanes we have. So for those of you that are interested in trying out, if you have a Parrot Mambo drone and you would like to try out the Raspberry Pi and see how it works, you can download the image, so you can write to the SD card. Again, we'll talk a little bit about what are some of the parts of the Pi that will help you understand what are some of the things you do with it. So we used the Pi 3 in this test, but you could also use a Pi 4. Pi 4 is just the newer, more powerful version of the Pi. It has USB ports, it has the Ethernet port, it uses an SD card, same as a memory card that you put in your camera, and it comes in different processing. It comes with a processor, but you have the choice of RAM on it. So basically, the onboard memory that you have for running applications on the Pi. And it runs from USB-C power supply, and it has two micro HDMI ports. We used the Raspberry Pi 3 because it was, again, a lower cost point, as well as it's powerful enough to be able to do everything that we wanted to do with the drones. And so if you it doesn't matter which version you use, both versions work perfectly fine. The reason for using Pi 3 is it uses USB, micro USB charger, just like a lot of the Android phones are charged by. And so we figured that some of these kids who don't have access to internet, they probably don't have a lot of other devices. And so giving them something that is readily available, like a power supply for the Pi, or hooking it up to USB keyboard and a mouse with HDMI cable instead of micro HDMI cable for the Pi 4, we thought that it would be much easier of a device to hand out to kids because they can connect it to different peripherals as they want.
I did want to just weigh in with one piece. Jigger had mentioned there briefly about the difference in the ports coming out, and the story is really simple. It's all about moving pieces. So with the Pi 3, you're really not constrained by needing to have a dongle to connect the HDMI ports or those types of things like you would with the Pi 4. So that was one less piece that wasn't going to leave the package. It pretty much was built on the board. So it made it, in this scenario, it made it really, really easy to ship out the Raspberry Pi with an HDMI cable, someone that may be a bit mousedly challenged. There's only one place where that adapter could go in. With the newer version of the 4, as you see here, it's a much more robust system, but unfortunately there is 2 HDMI ports built into the board. Which one do you plug in? How do you get the dongle in? So we really were going for that experience and simplifying kind of that user experience to make sure that we could do this with minimal tech support along the way.
Yeah, and because this was going out to kids and families, we also wanted to make sure that it wasn't too much of a burden on them to start plugging it in and using it. And so some of these choices were made because of that. And so we had, as part of the sort of the presentation that we did with the teachers, we made sure that they knew just some of the keywords as they were getting familiar with the Raspberry Pi. A lot of them had never used the Pi as a computer devices, and it does use Linux, which does have some terminology that is different from your Windows machine or your Mac machine. And so these are just some of the terms that we sort of laid out for them ahead of time so they're aware of it. And so once we also shared on why it's important to use the Pi, not just for the drone project, but for other STEM related projects. And not even STEM, just not specifically focusing on STEM, but you could use the Raspberry Pi at many different in many different ways. And so I'll play this video. It's a short video, and it's from a kid from Pennsylvania, so that's another reason I like to play this. But this really talks about the depth of projects that kids can build using the Raspberry Pi. So even if it wasn't drone specific, so if kids wanted to build something that was a lot more than the drone, but drones just was a stepping stone into getting them familiarized with the Pi, they could do a lot of different things with it.
I'm Toby Gobler. I'm from Dover High School in Pennsylvania. This is my tic-tac-toe robot. How it works is you have a paper here and you draw an X or an O. You press the button and this camera will take a picture, and then it decides where to go from there, and the arm will move out and draw a shape. I found a computer vision library online called SimpleCV, which I used for the X and O detection. But what I use is it looks for a shape inside the squares on the board, and then for an X, it'll know that in the middle of an X there was a cross, so there's color in there. But inside of an O, it's empty, so there's no color, and that's how it differentiates between the two. Yeah, there are some people who get a little upset that they lost to a robot. Made me really appreciate working on a long project, because I worked on this all semester. It was the biggest project I ever did. I'd never worked on a project for that long before and had to stick with it. So it was really interesting to see how a project develops over that much time.
So you can see from that on how how much effort and dedication there goes into building a project, but also the depth of the projects you could build with it. And what's nice about that is that you could build that project without having any access to the internet. So once you have the libraries downloaded for image recognition, all of the processing and all of the machine learning that happens, all of that happens on the Pi itself, on the Pi, the device itself. Because it's a computer, it can do a lot of that processing on the Raspberry Pi itself. And so you don't need to go out to the internet and pull the information down, just like an Arduino would need to do or a microbit would need to do. with the microcomputer, like a Raspberry Pi, it can do all of those things directly on device. And so all of the image recognition, the machine learning behind the device, all happens within the device itself, which is why the Pi is much more powerful than the microcontrollers that you see out there, because it's an all-in-one device. So you could do a lot of those things without having to rely on other devices to do it with. And you can program all of those things directly on the Pi as well. So you don't need a second computer to program it. You can do everything on the Pi, have it process, have it, you can write the code for it on it. You can do pretty much the entire process of building a project on it. And one of the other things that we talked about and focused on was really this design thinking idea. And so many of you have probably seen design thinking, whether it's engineering by design or just design thinking process that you might have seen. We particularly use the Stanford D-School's version of design thinking, which puts a big focus on empathizing with people. And so we'll talk about some projects toward the end of the session here, which specifically talks about solving real world problems, which are problems that many face. And especially during the pandemic, there are some great examples of how drones were used to deliver whether they were testing kits or just supplies to people who were quarantined or stuck indoors during the pandemic. So I think some of these things are coming out because people are empathizing with what other people are going through, and so that process is really important when talking about it with teachers as well as students on why they should be sort of thinking about it from a design thinking perspective. With one of the other things that's provided from the Raspberry Pi Foundation is this curriculum that they have, which really focuses on different criteria or parts that you want to have your students learn. And so if you want to focus on something like process input data and monitor or react to the environment, if you click on that on the digital version, which is available on the web, it will actually take you to projects that are related to that particular task or that particular goal that you're trying to help students learn. And so this is just there for informational purpose in case you're interested in finding out what other projects can you do outside of the drone projects. We always share the digital making curriculum because it's a great resource for finding other projects that your kids can do or you can do with your kids. So physical computing is how we really introduce a lot of the Raspberry Pi concepts to both teachers and students. And physical computing just means connecting the physical world to the digital world. And so we're sort of doing that in the sense where we're connecting the drone, which is a physical thing, to the Pi through digital means, and we're controlling it through digital means. And so that's really what the focus on physical computing is, or the idea behind physical computing is. I'm not going to play the video, but the video is there in the slide deck if you do want to sort of check it out. These are just examples of projects that you could do outside of the drones. Again, this is sort of to help both teachers and kids know that this is not just one-off device. It's not like a device where you can just do one thing with. You can do many different things with it. And you can combine a lot of these projects. So you can build a weather station, right? So, if maybe you want to have an optimal wind conditions to fly a drone, you need to know that. And so maybe you can build a weather station which collects information about, what the wind speeds are, and it only lets you fly the drone if the wind speeds are below a certain level, or the temperature, right? Depending on how far you want to go, the temperature might come into account because the batteries on the drones don't last that long. And the more normal temperature it is in the 70s and 80s, the batteries are more optimal to behave. So it might go a little bit farther, whereas in cold weathers, the batteries don't behave as well, and so it might not go as much. And so those are some of the things you can integrate with a weather station that you build on the Pi that then lets you control the drones. And so again, these are some, various ways you can sort of combine different projects to make it a better learning experience for your kids.
We found that, most students, their prior experience with drones are within the ecosystem or the controls that are developed by the manufacturer. Kids will have opportunities to fly drones, but they don't have really opportunities to explore drones in a system, or think about how they might connect to other things. And this platform, the Raspberry Pi, and using Python, does have that openness and that flexibility to allow that kind of thinking.
And then just remember that the whole idea is that how do you do this in a completely offline environment? What's nice about that weather station idea is that you can add a temperature probe or a wind sensing device to the Pi. You can wire it up, and it'll actually collect the information in real time versus it going out to the internet and pulling the weather data down. So you're actually building the sensors that will collect the temperature, humidity and everything, with the Pi, rather than having to rely on on the data from the internet. So this is real-time data that you're using to be able to fly a drone, and all of that can be done without having access to the internet, or without needing access to the internet. And so, what all do you need to get started? Well, all you need is a Pi, and the way that we have our Pi set up is all you need is to power the Pi. We use Raspbian or Raspberry Pi OS, which is the operating system it runs, and we have slightly modified it so you can actually connect to it. And so what we do is we have a additional Wi-Fi dongle that you have to plug in. So there's Wi-Fi that comes built into the Pi already, and then there's an additional Wi-Fi dongle that you can add. In our case, because we're completely offline, we don't need to worry about any of that. We just use the built-in Wi-Fi, and we turn the Raspberry Pi into a hotspot. And basically you connect to the Pi directly. And so you could have another device that you could use and connect to the hotspot that the Pi creates. Or like we mentioned before, you can hook the Pi directly up to a TV with a keyboard and a mouse and use it without relying on another device. So there are really two ways to connect to it. So for districts that were one-to-one, that handed out Chromebooks or any devices that their kids took home, they would take the Pi home, and in addition to those devices, and connect from those devices. For those districts that didn't have a one-to-one program, all they need to send is the Pi home with their kids, and they could connect it to a TV or a monitor if they provided one, and then a mouse and a keyboard is needed. And then what we used was Thani IDE, which is integrated development environment. This is really where you do the programming. This is where you type the code in. So Scratch, for example, is a block-based programming. You do everything on Scratch. Now, Scratch is also available on the Pi. The offline version of Scratch obviously is available on the Raspberry Pi. There's another program called EduBlocks, which is also available on the Pis, which runs offline, which is, again, block-based programming. For Python, we use the Thani IDE because Thani has really good debugging information that it gives you, which is a really good skill that your students need to know when they're writing a piece of code. And so we opted to go with Thani as a way of developing a lot of the coding pieces. And so we started with something called Python Turtles, which is a simple programming, task or a programming library that gives you ability to control what's on your screen. And it looks like a turtle, and so that's why it's called Python Turtles. And I'll let sort of Tom talk a little bit more depth about why we decided to use Python Turtles and what how easy it is to help kids sort of get engaged with this, especially if they're just starting to learn programming.
So as Jigger mentioned or pointed out, one of the roles of the Raspberry Pi really was to work as that digital library and being able to provide resources on the Pi to a secondary device or on the Pi itself. So with the choice with Python Turtles, we were really looking as well at that, kind of the UDL, Universal Design for Learning mantra of no tech, low tech, and high tech. And one of the things, this really takes its form from many of you, probably if you have stress highlights and showing those laugh wrinkles, have remembered the PC logo days of old, and that's really what Python Turtles capitalizes on. It's just a hybrid of that. And for us, keeping in that UDL framework, one is if a student did not have any tech or was struggling with tech, they could actually work through the process of, just as you see on the screen, very simple language. You have an instance of a turtle called T, then you move it 90 degrees forward 100, which is a distance. So it lent itself to basically even being able to pick up a ruler or a protractor and measuring things, or even if without those, scaling that up to a mobile device, drawing out the sort of the flight plan, the pattern, what may be there. And it very quickly provided that sort of comprehensive UDL experience for those struggling students across the board. One of the other pieces with Python Turtles, which is a huge, I think for kids, a great onboarding piece. It does begin to teach some of those program concepts such as object-oriented programming, just with the simple script you have here on the screen, which would draw a square, it looks like. You have the idea of an object called turtle, which is instance and the letter T, and then you're providing methods with variables that go across the board. And again, there's all sorts of many doors that you can walk through after you go through that initial phase of what this looks like. Just for those who may not be familiar, I think the next slide that comes up basically goes line for line. Jigger, if you want to go ahead and advance, that goes through and tells you a little bit about what each one does with the syntax. Again, really easy to come through. We've also used some unplugged analogies within our camps, and also face-to-face and in person, where we use, since Eric's on the call, Eric the robot, and we use the ceiling tiles in our room to count distance. Eric the robot has to go 3 ceiling tiles forward, turn right, then go 2. And again, it's a really great segue to go back and forth from that physical space into the coding realm to talk about what's there. Then again, if we want to get a little bit more, just to build upon it, we can simplify this and talk a little bit more about functions and loops and how you can be in, and again, just begin to scaffold and layer one on top of another. So after you have this simple, how do you make those simple instructions? And we can introduce the for loops. And then lastly, of course, we can also talk in terms about what happens when you write bad code and go into this epic turtle forever that continues to spin. How do you stop that, and how do you debug your code? So that was really great with those. Now, after that sort of baseline, we could really start talking about what's going to happen with a drone. And I think, with this is where, again, leveraging some of the shape libraries, and as you'll see here on the additional, some logic that's on down the next couple slides, you can begin to say, all right, we'd like for you to go ahead and, you can ask questions and then pipe in variables into the code, or you can begin to lay out some logic components, or say, this is what the drone's going to do before you even touch the flying pattern of the drone, or put that in place. So again, thinking about where this would be in a classroom, or also in this case in someone's home. These are made to be indoor drones. So if you have the area, you're able to fly those. Unfortunately, in some houses, there are some obstacles like brothers, sisters, things on the wall. This sort of pre-planning or pre-flight planning was really key to come in and allow that. The other piece that I think it's a subtlety with the selection of Python Turtle is really this idea of, sometimes students are enamored with the idea of becoming a game programmer or coding, and at the onset they get really excited about, hey, I'm going to learn how to code, and then after the 5th line of code they immediately get disenfranchised, or they get disenchanted by the idea of sitting and writing lines of code. the instant gratification of seeing something spin on a screen or draw or come up with some artwork is really, really appealing to many of those students. So again, just as how could you reuse this or recycle this, or how does this fit in? Our hope was that students would begin to run with the drones, they'd enjoy the experience, but in reality, we also wanted to backfill that what if it didn't stick? How else could a teacher use this, as well as if we were working one-on-one with a student remotely? How could we get them still engaged with coding and those types of things? So I think the next slide that comes up is really just some other code pieces that were used. Again, those are pretty indicative to the Python library. And then I'll let Jigger pick up with GPIOs, but as he's catching his breath, this idea was, one, this is what happens on the screen, which was great. The one command that we didn't talk about that I would say what really was the connector piece. When you begin to look at the Mambo code a little later on for the Python or for the Parrot drones, there's this idea of lift off and then also take off and then also land. So in turtle terms, that also could be pen up and pen down. So there was a nice crosswalk between the commands that were already built in as functions and libraries within the turtle graphics that was easily adaptable over to the drone space. And there was not much. So again, you could do your whole flight plan just using Python turtles without wrecking the living room, and then turn it on and move that in with a really easy change to allow that flight to happen, and they could see it sort of live in the physical realm with the drone acting upon the code that they built. Now back to Jigger.
Yeah. And so this really helped kids sort of visualize on screen what the flight plan might be, and then they take the same code and apply it with the Parrot Mambo by replacing basically just renaming the variables or just changing the numbers. This one goes each pixel, instead of pixel they would just be thinking about it from the time frame of how long do they want something to go in terms of time. And so these two were really two activities that are really closely correlated, because once you get an understanding of how to operate on screen the Python turtles, you can really replicate it with the drones. And so it helps kids visualize something on screen before trying it with the drones. Because once you fly a drone, once you say take off, it's going to take off, it's going to go. And so you want to have them sort of play around with what that might look like before they even try it with the drones. And so Turtle Pythons was really a good way of doing that. And then we talked about a little bit about GPIO pins. The Raspberry Pi does have 40 general purpose input-output pins, which lets you connect sensors and other devices to it. And this is really so kids can build on top of the drone. So if they wanted to build a controller using a breadboard and 4 buttons that they can now press the button to control the drone, they can do that. All they need is a bunch of wires, a breadboard, and a button to sort of wire up what that might look like. So we didn't go in depth with GPIO pins, but we did sort of share some resources on how they could do that. And all of our code was also available through GitHub, so we walked the teachers through the process of how do you start using GitHub with your students. And so we had activity cards that we developed as part of the project, and this was really for kids to once they have the drone basic understanding of how to take off a drone and how to make it go forwards and backwards and then land, they could do a lot of different things with it. And so one of the things that they can do is build a interface on the Pi, so when they run the program, it actually comes up with a control board that lets them click a button on the screen to have the drone take off, click a button on the screen to have the drone land, or have like an emergency button created. So if something goes wrong and they want to land it instantly, we can hit the stop button to sort of stop the drone completely. And so we helped them do that through the introduction of a graphical user interface, or a GUI, which lets them build interactive applications directly on the Pi itself. And so this really helps students sort of take ownership of what they could do with the drone. So now they're not only programming how to operate the drone, but they're building a system on the Pi itself and building a self-contained application that lets them do the controlling of the drone. What's nice with this is because it's built with Python, you can actually bundle this app and run it on a Mac or a Windows machine as long as they have Python installed on it. So once you program this on the Pi, if they wanted to, share the program with someone who has a Windows machine, as long as they have Python, they could run the same program on a Windows machine and connect to the drone over Bluetooth and be able to do everything that they're able to do here. So it really helps them understand how they can build systems that are cross-platform with interfaces and everything that comes with building a program. The other thing that we talked about were hats. So hats are hardware attached on top of the Pi. So it uses a 40 pins that you can use to attach it on the top of a Pi. So as I talked about the weather station project earlier, this one, the Sense hat, has a temperature and a humidity sensor on it. It also has a gyroscope, accelerometer, and a magnetometer. So that's compass basically. It has a mini joystick on it as well. So one of the activities you could do is use the joystick to control the drone. So you can have the drone take off or land or move back or forwards, which then be controlled using the joystick. But what's nice is you can also, do the monitoring. So like I talked about, having a certain temperature for the drones to take off. You could sense the temperature before it can take off. With the gyroscope and the accelerometer, you can actually rotate the Pi to mimic a sort of a physical controller for the drone. So if you move the Pi forward, you can capture that data and pass it on to the drone, so the drone moves forward. If you move if you move it backwards, then it'll move the drone backwards. If you move it down, then it'll land the drone. If you move it up, then it'll take the drone take off. So you can use some of the sensors that are built into SenseHat to interact with the drone. So we talked about how do you make a simple project like that, and how do you sort of use the SenseHat to do that. And then the platform that we use to deliver a lot of this is something called Kolibri, which we mentioned it a couple of times during the presentation. And this is really how we preloaded all of the learning modules ahead of time, so the students didn't need internet connectivity to learn a lot of this Python programming, as well as how do you put the drone together. And so the way you do that is, again, you connect to the Pi, which I'll do in a second here. And then show you what the Kolibri platform looks like. So what Kolibri is an open source platform, which is free. It's available on the Raspberry Pi and many other devices. And the whole idea behind Kolibri is that it lets you pre-download content from various content libraries. So Khan Academy, for example, it has a large library of content that's available. CK12 has a lot of content that's also available on the Kolibri platform, but you can also create your own content and upload it to the Kolibri platform, which then what lets you do is pretty much you're able to download ahead of that all of that content onto the Pi and then send it out to the kids. And when kids turn Raspberry Pi on and connect to the platform, now they are basically able to stream a lot of that content directly from the Pi, so they don't have to connect to the internet. And so the best way that I can describe this is if you're going camping where there's no internet connectivity and you wanted to watch your Netflix movies on your iPad, what do you have to do first? Well, when you do have internet, you download all of that content ahead of time. And then when you go camping, you don't need internet access to view those videos because they're locally stored onto that iPad. Basically, we're doing the same thing, but we're doing that on a Pi, on an interface which has a lot of features onto it. So it's low cost. There's also syncing ability, so when the kids do go back to school, they can hook the Pi to the internet connection at the school, and they'll update the content or download the content and sync the content. But it also lets you track, lets the teacher track some progress that the students made within the content that they're looking at on the Kolibri platform. So it's a really powerful sort of tool for offline learning that lets you do a lot of different things on it.
It's important to, it's worth noting that, while we were using Kolibri for the drones, there was a parallel work group, an initiative that that allowed folks to develop other curricular materials that would be distributed to kids without internet connections using this lightweight learning management system. So the idea that the kids would be learning remotely, but also having some of these hands-on experiences that would be difficult to deliver in other ways.
Yeah,
I
so
was
really
going to add
quickly,
it to,
go ahead.
oops, with Eric's point that he'd mentioned. One of the reoccurring themes quickly with the choice for the Raspberry Pi was many of you currently have or building out your STEM libraries and putting in devices to go out for loan. And one of the appeals collectively for the Raspberry Pi, because as Jigger mentioned at the beginning, it is a microcomputer. The versatility of being able to use it as a Swiss Army knife for a variety of scenarios really has a lot of appeal. So one, it was for using it with the drones, but then the Raspberry Pi really doesn't have to sit in the drone box if that program, let's say, would not stick afterwards, or there's another opportunity or another instance where you need such a device for microcomputer to go out to program things. So again, it just lends itself to being very, very flexible back in the classroom. Sorry, Jigger, back to you.
No, yeah, and so we were able to use Kolibri to do a lot of that. And again, I just want to point out that there's a huge content library that they have that's available through Kolibri, and its tool really meant to be self-paced, and you can build learning pathways within the system, which made it powerful. And so what we were able to do is take that and we built a Google Classroom course for the drone, which we'll show you in a second here, which we were able to import into Kolibri for to be able to be distributed through the Raspberry Pis. And so the way that it worked is they would connect to the Pi. So I have a Pi here that I have up and running, and so they had two options. So they can go to the hotspot Raspberry Pi. So you can see I'm connected to the Raspberry Pi hotspot, and then I type in an address in any browser, and I'm able to sort of remote into the Pi, or I can look at the Kolibri platform. So when I launch the online learning platform or the offline learning platform, you'll see that we have three sort of channels, or that's what they're called. One is exploring drones through programming. This is a Google Classroom course that we created, which has everything that you need to be able to do everything that we talked about. So introduction to drones talks about how do you build, how do you code, how do you fly, and there's an assembly guide, or there's a disassembly guide, as well as the assembly guide. So all of these are assembly guides. So you can see there's it's in a load of PDF. There's also videos here that are available, but this is basically a PDF walkthrough of how do you build it. You can see here, so do it yourself. You can see all of the components that come in.
One quick point of clarity, as Jigger mentioned, there is a conversion tool that we worked to have created that allows you to take everything is built within the Google Classroom, a script is run, and it converts the Google Classroom to a format that can be put into the Kolibri system.
Yep, so you can see that there are videos for the unboxing. So this is how the drone came in different parts, and they had to put it together. So all of those resources are available for kids. Again, all of this they're able to do without connecting to the internet. So all of this is just loading directly from the Pi itself. And it's laid out in a logical way, so they can just continue on. So here, it talks about that Raspberry Pi video. Once I'm ready to move on to the next sort of lesson, I can sort of click on it, and it'll take me to the next section in the lesson, and so on. So you can see that I'm able to look at everything that I need to directly from the Pi. We included programming tools, so those were just resources. We included some Python introduction code. We included some, how do you connect to the Pi? But we also included some extra resources, such as a complete guide, to the GUI 0, which is the interface that we build, the library for that. Essentials guide, again, same as another additional ways that they could connect other sensors to it. A cheat sheet that helps them with Python programming. And so we were able to sort of include a lot of those resources to prepare them if they needed help. This wasn't meant that some students might already have some knowledge in Python and they might have not needed a lot of this, but for those that didn't, we wanted to make sure that they had everything there. The other thing that we included was specific content from the Khan Academy that would help them just get a background understanding of core concepts. So they need to know some math to be able to, fly a drone in terms of, figuring out the distance, the timing. There's some basic math they have to do. There's some, algebra that they have to do to figure some complex situations and things out. So we included Khan Academy lessons by grade, as well as some science and engineering, because I think there's some physics involved and they need to be able to understand how the drone sort of flies and what are some of the physics behind it. We also included English language arts because it's important for them to be able to describe the process in which they did a lot of this building work or flying the drone work. So some of those lessons were included. We also included fit simulation. Again, we included all of them, but physics, math are the two that are probably most important when they're learning about drones. So all of this, again, was available completely offline through the Kolibri platform.
And again, this is serves as a model for how students might access, teachers might facilitate a physical computing or a drone course alongside, more standard courses in math or language arts or sciences to students that are home without an internet connection.
And so here's just a quick couple slides on how to connect to the drones from the Pi itself. And so there are two ways to do that, and we talked about it. And then we, had a sample code on how to get started. And so this might look a little scary, but it's really not. This is just importing the library for the drones. Here we're defining which drone we want to connect to, the MAC address of the drone. And then it just goes through the process of connecting to it. So it tries to connect to it 3 times. If it fails, it'll try again up until 3 times. Once it's connected, it will sort of sleep, means it just pauses for a couple seconds, and then it'll take off. It'll wait 5 seconds, and then it'll land, and then it'll wait 5 seconds again, and then it'll disconnect from the drone. So it's basically taking off, hovering for 5 seconds, landing, and stopping at 5 seconds. And then we included some a little exception code. So what this does is that it runs this. If it notices that there's something wrong in the code, then it automatically lands it and disconnects it. And so why would you want to do that? Well, because if you made a spelling error, or if you coded, if you wrote the wrong function, if the drone takes off and your program stops, then the drone's just going to keep running. There's no way to stop it. This is not like your typical program where if you stop it, it's going to land the drone automatically. It doesn't know that. It's doing exactly what you told it to do. You told it to take off, so it's flying. And now if there's an error in your code, you need an emergency way of stopping it. Because right now, all it knows is to take off. It doesn't know when to land. So when the program stops, there's nothing telling it to land. So it'll just keep going. And so what we did was, if it notices a code error, then automatically just lands the drone no matter what. And these are things that you should be thinking, having your kids think about when they're programming devices like this. And so we help them sort of give them a code sample of how they're able to do that. And then one of the things that we also included were some real life projects. And so on the Kolibri platform, we included a sort of a project that they could do, which is a mimic of a real world project that they're able to do. And like I mentioned before, they were companies, they were utilizing drones to deliver testing kits during COVID. There were drone deliveries for food and medicine to those remote areas where people were quarantined and they couldn't really get out. So there's to limit the spread of the virus. But there are also, other examples across the world. And so I'll let Eric sort of talk about this, but this is another really good example of how drones are used in real life, and especially where there isn't enough infrastructure set up.
So this particular challenge utilized Google Earth, and the students are challenged to deliver. They watch the video and see how this is happening in the real world, and then they use maps to plot out a flight path from a hospital in a city to two remote villages that were in need of medical supplies, in this case blood. And so it's providing that kind of real world context. Where are drones being used in the real world, and what kind of challenges do the designers and the engineers and the operators need to consider when they're utilizing these? So, at its simplest, it was using a map and estimating flight paths and distances and durations. But with more complexity, you might consider in this kind of mock simulation, creating obstacles like mountains or wind, those kinds of things to add complexity to it. So again, this is just a real world context for a short challenge for the students to program their drones.
I'll leave the bit.ly link up here so you can sort of take a look at it. And so that was really it in terms of we went a little longer than our 30-minute session, but that was really it on what we try to sort of do with those teachers and help them get ready to use it with their kids, especially kids who didn't have internet access. And really our goal was to provide a very much a similar learning experience to kids who don't have access that kids who do have access get. Kids who do have access have resources like YouTube, Doodle to sort of look and search for stuff. Kids who don't have access often lack those resources, and so what we try to do is include a lot of that in our offline learning platform, and help them with every resource that they might need, so they get the same learning experience as those that have internet access would. And they can still do, things like program a drone or, build a weather station or whatever they sort of put their mind to without having access to the internet. Because I think we often equate having access to the internet being ability to do a lot of these things. And when we don't have that provided to our students, we provide them with a lesser experience, by just giving them, paper worksheets, or maybe we give them a USB drive with just, worksheets that are digital, maybe digital textbook, but nothing that's more interactive. Whereas in this case, it doesn't matter if you have access or not. You can still program a drone. You can still, find, coding resources without having access to the internet. And that was really what our focus was, and that's really what we try to do as we delivered this workshop to the teachers. Tom, Eric, I don't know if you have any last minute things you want to add, but during the live session, we'll be happy to take any questions, concerns, nasty remarks that you have. But I'll push it off to Eric or Tom if they want to add anything.
I think the only addition to what we put out, I'm going to be, truth be told, drones are not something that was in my space. However, through the IU, we also co-sponsor a scouting venturing crew program, and it was very interesting to me to watch The participants of that crew, we were able late in the fall to have a socially distanced meet and greet, so to speak. But the key piece of that was building drones. And it was really, really interesting to see just how excited the youth got with, in that case, I'll call them youth because they span multiple grades, but they were totally enthralled with this idea of building the drone, let alone flying the drone. And then that final piece, which was the capstone, really getting in and tweaking and programming the drone. There was a lot of excitement in the air, and it was really, really, I think, for lack of a better term, fulfilling to watch that all unfold. Many times, we struggle to look for these opportunities where you can really be the guide on the side and just let the students or the youth go in and explore this on their own. And from a firsthand experience, I really have saw that unfold. And I hope that that's available in your space and you're able to take some of this and maybe partner and come up with that for the students. I think it'll be very rewarding.
I don't have anything to add. We hope you can join us in June, and we'll be happy to share, listen to your feedback and share other greater detail of our experience. Thank you.
Yeah, and again, feel free to reach out either of us through our emails if you have any questions or if you want to try this out within your own districts before our June presentation. We're more than happy to talk and help and discuss how that might look like in your specific sort of district. And so feel free to reach out, but if not, we'll see you on June 23rd from 1 p.m. to 2 p.m. which is when our Q&A is. Hopefully you can join us. And again, thank you for watching this extra long presentation, but hopefully useful presentation.